All right, good morning and happy Monday. It's 5:47 a.m. and I'm planning on doing the Leak Code Daily Challenge for today. So I'll share my screen and start jamming here. Okay, so I haven't really done much this month. All right, seat reservation manager, let's do this. 1845. Looks like I solved this before, about 3.5 years ago. Anyhow, let's jam on this and we'll do it in all the languages. Good practice. It's 5:47 a.m. or 4:48 now. Okay. The N seats, take the smallest value and unreserved. Okay, if we're continually cherry picking the smallest, then this is a green or like a big light that says, hey, we should be using priority queue. Right, so I'm going to implement this thing then. 5 seats. Okay, 1, 2, get back to yeah, so yeah, we should just be able to stick in the queue, mark which ones have been reserved. We have to mark which ones have been reserved. Maybe we'll just trust that the client, yeah, we'll trust here the input is correct. Okay, so that makes the code a lot easier, just making that assumption. Okay, so anyhow, the game plan here then will be to use a priority queue here, right? Basically, I'm in heap to continually extract the minimum available seat per reservation. Reservation. Okay, let's do this. It's 5:49. Let's start the implementation. Let's keep track of what my time is going here. One of these days it'll be a contestant rather than participant in the contest here. Yeah, let's start jamming these things. So self dot q be our heap. It doesn't really matter. I don't know if we need to use in, do we? For assuming the input's correct, then does it matter? I see. So wait. No, yeah, we do want to be able to extract from the queue, right? So we'll just say I for I in range n, and do I plus how about one based index. Take is self dot q heap pop from that guy. Just return that. Heap push self dot q. Okay, let's see what happens here. It's 5:51. Some syntax errors expected. Delete that. Okay, that looks good. That's the only test case we have. All right, let's submit it. It's 5:51. It's about 3 minutes. Okay, cool. So that's accepted. 5:51. 3 minutes. And anyhow, the reason I know that this set off an alarm, right, for minimum queue, or yeah, minimum priority queue, minimum heap, whatever you want to call it, is that I've seen this before when I studied the algorithms from this fellow named Tim Refgarden on Algorithms Illuminated. So this is part of my GitHub repository. So you can look here. And basically, as part of this dude's, I think it's part of Dijkstra, this dude basically says, how heaps can be used to continually cherry pick the minimums. I'm pretty sure this is part of part two, where it's like, okay, like this is part of the toolbox, and it's like a huge light bulb shines. I'm pretty sure for Prim's MST we use the same thing, right? The min heap in order to take each next edge, which is part of the frontier, which is the first part of the edge. Like the first node is within the MST, and then the second part is outside the MST. Same thing for Dijkstra, right? Use like this concept of the frontier with the min heap. Okay, anyhow, that's basically some of the background, right? So I did this in 3 minutes today, but the only reason I did this in 3 minutes today is because, like, whatever it was years ago, I planted these seeds, right? And understood the algorithms and data structures from Tim Ruckart. Okay, so anyhow, we'll do this in the other languages here. I'll post this, and if y'all have any questions, feel free to ask me on the discussion board, right? So, okay, set, this is kind of silly. A set is ordered. So indels, that is insertions and deletions, are logarithmic operations, whereas we could use just, actually, yeah, we can just use an unordered set. Oh, I see. Okay, so we are using the order here. Okay, so yeah, instead of a heap, we could use a set, which is basically the same thing, right? Heaps are logarithmic indels as well. Right, okay. This is kind of silly though. I'm gonna update this. Might as well just use a min heap rather than an ordered set. And just clean this up a little bit. Right, so for this guy, I can just change it into a lambda. And just return this guy. I think is a little bit cleaner syntax. If you don't have to write something, might as well not, right? It's less to look at. And I think this simpler is better. That one returns none. Okay, I think that should be fine. I think that's a better solution. Just get rid of white spaces, fine, whatever. Okay, let's do this. I'm gonna update this one in C++ at the end here to use a priority queue instead. Using a priority queue, I think, is more self-documented code. So you can obviously see, yeah, this is a min heap, right? So we're continually cherry picking the minimum available. Whereas here you have to think, oh, okay, you have to know C++ set is an ordered set, right? Which is not as straightforward. And straightforward and simple is intelligent, not complex, right? Straightforward, simple is what we're aiming for here. So as part of the description, we'll just say use a minimum queue to continually cherry pick smallest I value from 1 to n inclusive. There we go. Okay, so speaking of C++, you might as well do this in C++, right? So it's cool. Let's do this. So using, we'll just call it a min heap, right? Yeah, min queue have a priority queue. I think by default it's a max heap in C++. So, and oops. Yeah, as we have vector of integers. Just keep this nice and short and sweet if we can. And then we'll use the ordering. Right, I think. If it's not right, then we'll just change it. It's either greater or lesser. I forget. Let's see what happens. There's the ith seat, 1 to n inclusive. Or actually, let's look at the constructor for the priority queue. C++ priority priority queue constructor. See what we can do to construct it. From range T since C++ 20. Interesting. Never seen this before. C++. Range constructed. Wonder if there's an example. Priority queue constructor. Ranges to containers. Yeah, that's what I want. I think, right? Is range to container? No, this is just a proposal, right? And I want the actual syntax of it. Yeah, I want to initialize this thing in the constructor. 32. Okay, that's not one. All right, where's the constructor one? Okay. That's not helpful. I'm just sticking it here. What the? Come on. Really? A generator function or something. That's what I was looking for. What's this T range thing? Range. T range. Intercompatible range. Interesting. Wow, that's awesome. Okay, so this is basically C++'s version, which is extremely verbose, of functional programming. That's cool. I wonder if we can use this with the priority queue there. To vector. Let's try this. And I'm pretty sure C++20 is supported. So we want 1 to n. We don't need any transformation, but I do want to change it into a min queue though. Let's see if this works or not. Files. This is cool. Oops. That's pretty awesome. Views. Oh, dang. Okay, so what the heck? This views. Views? C++ views. Since C++20. Oh, dang. So it must not be supported yet. This sucks. I thought LeetCode supported this stuff now. Okay, whatever. I'm wasting a lot of time, right? So let's just do this the old-fashioned way procedurally. But eventually, C++ will, it looks like, get to the point where we can do some verbose functional programming concepts, which basically describe what to do rather than how to do it. And C++ is the opposite, right? C++ is a procedural language where we say, okay, this is what we're doing, or no, how this is how we're doing it, right? How we're doing it. And from how we're doing it, you can reverse engineer what we're doing, right? Which is kind of an old school backwards concept. Right, nowadays we do the functional programming, and then like the lower level implementation details are taken care of by the computer. Things like features and tasks and such in C++ are much better to use as a higher level abstraction compared to dealing with base threads, for example. Right, the computer's good at that stuff, so let the computer do that stuff for us. Okay, anyhow, before I keep rambling on, min q implement the actual instance would be this guy, our q. So q to push each ith value from 0 or 1 to n inclusive for one base indexing. Here we'll say auto take goes q dot top, q dot pop, return what we take. You say next, how about next in line, next. Okay, and then this guy, do q dot push I. Oops. Okie dokie. Yeah. So it'd be much nicer to initialize this thing up here if we could. But it looks like that's more of a C++20 type thing. All right, it's a decent enough solution though, right? It's pretty straightforward. We're using a minimum priority queue, right? And we're pushing 1 through n inclusive onto it. Each next value that we reserve is the top of the queue, right? And then when we unreserve something, we just push it back into the queue as a candidate for the top eventually here. Okay, so comparing today's C++ solution with yesterday's, or not yesterday's, but whenever it was, like, actually quite a while ago, right? Say like 2.5 years ago. So that's cool to see improvement, right? This is not a good solution in that this is not self-documented. It's not very straightforward. This is an ordered set with logarithmic indels. It's not clear that this is the minimum, right? Compared to this guy, it's like, okay, this guy's the minimum queue. It's obviously a priority queue. And we're pushing each value into an inclusive here. That's kind of cool the way this is done. Yeah, might as well take that then. And then, yeah, just take the next as the top of the min queue. So it's pretty straightforward. Whereas this is like, what the heck is going on? You know, this is junk code. So this is junk code in that it's like, I would consider this like clever code. And yeah, clever code is not clever at all, right? Complexity is not intelligence. Intelligence is simplicity. Okay, so anyhow, let's do this and let's go do this then, right? Just shrink it up a little bit. That's fine. I mean, it's not terribly too confusing just to say we're just pushing each ith value. One statement. Okay, that looks good. Already, yeah, a little bit less white space for the context of the code is fine, I think. In production code, I definitely would want to see more white space, right? Otherwise, just make a ledger light up. Okay, anyhow, that's cool. We'll do this in the other languages, then I'm gonna get out of here. Let's do var private q is a priority q with the constructor upland c tone for a priority q. If we can initialize it with a collection 1 through n inclusive, that'd be cool as a comparator. It's set mutable collection. Okay, we should be able to use a mutable collection for the constructor then, right? I think. Let's see what happens. Use a priority queue integers. So when we initialize this thing, we want q is equal to, oops, just like this thing. Initialize with the range 1 through n inclusive to mutable list. See if that works. Oops. Maybe, yeah, okay. Looks good. Let's do this then. Return q dot full. Q dot add the ith seat number back. Okay, I think that works. Then we can shorten this up a little bit. Sure is taking a while. Okay, submit it. I guess you gotta pay the big bucks if you want this to run faster. I wonder if we can just stick this on one line instead of initializing it down below. I think that works okay. And then this guy we can turn into a lambda. The other guy, I think we can turn it into a lambda as well, right? For this guy equals, just return that guy. A little bit more concise, right? We need to take a function with no parameters. Oh, okay, that's fine. Yeah. All right. And this guy we can turn into a lambda as well, I think, right? So taking this guy, just do this guy. Okay. Yeah, that was good. And once again, right? So this is good in the context, I think, of leak coding. Maybe not the best in the context of production code, but it's nice to see something short and concise, right? So you can see what's going on with the algorithm itself rather than get lost in kind of like the syntax and other details that are language specific, right? So try to keep it super simple. Okay, so what next? JavaScript? Okay, yeah, do JavaScript. So JavaScript does not have its own min heap that I know of. So I wrote one and I have a gist that I usually go to for my min heap in JavaScript. This guy, heap.js. So basically, I implemented this guy to mainly just to copy and paste for leak code. I think it's a good practice too. So heap manager, reserve, and unreserve. Okay, so I'm going to change the syntax of this a little bit. All right, so it looks a little bit more like an actual class with the constructor and stuff. Is it constructor or initializer? I forget. It's been a while. This q equals spread low dash range 1 to constructor or initializer. Forget. It's been a while now. 0 or 1 to n inclusive spread. Heap. Oh, there's no heapify function that I have, is there? Just a bunch of heap pushes. Okay. I'll just do this. Dash 1 to n inclusive for each ith value. Heap push to this queue, the ith value. Okay, and then reserve heap pop this queue on reserve. Oops, unreserved. Oh, bless me. Heap push. Oops. To this queue, that ith value. Okay, something like that. Oh, low dash. Oops, it should be low dash range. That's what I want. Range. Use low dash range. 1 to n inclusive. Okay, that was good. Okay, yeah, that's cool. Okay, so there's JavaScript. And JavaScript, Python 3, and Rust. Rust gives me the heebie-jeebies sometimes when I think of it. It really gives me a hard time. Okay, so Rust, it's RDQ, it's called a binary heap. Similar foolishness. Back sheet by default. So we can put a negative value in this thing to make it a non-max heap. All right, whatever. Let's see. Use the functions heap. Okay, so I need to look at Rust here real quick for the syntax of this thing. How do I stick this in here? Okay, so right here, to declare it and then make the implementation for it and return a new one of it. And Q will be our binary heap. Binary heap. Mute me. Be returned here. Signature. I'm gonna initialize this thing and then yeah, I'm not sure offhand how to write this. It's been a while. So I want to initialize the binary heap. I wonder if I can find an old last Rust one that I implemented. I can search my solutions for Rust or not. Mm, I remember doing this stuff, or I don't think I have any examples where I have me, just plain on me. don't know if this will work or not, but let's see what happens here. Let's be the ith seat number, seat manager, seat manager, expected function to construct, seat manager defined here. If that recursively invokes this guy, forget. I've seen generics. Q equals binary heap new. Can I just do this? Q. Just an instance of this guy. Oh, maybe it needs to be like this. Does that work? Take the Q later on. Missing generics. I need to actually read what it's asking. Okay, and she's pretty happy like that. Okay, so for I n one until n inclusive me dot q dot is it add or push? Push. Oops. Back here. Push I. Turn this guy. Let me just stick this on the line too. It's cool. Save some space. Save some space. Okay, and then this guy will make self-mutable. We'll fill in the implementation for it. And then this guy needs to be mutable as well. So what we'll return here would be self.q and like a pop function, pop and unwrap. Unwrap. Okay, this guy do self.q.push on. Oops. Okay. Yeah, so something like that then should work, right? Come on, big money, no enemies. Uh-oh. Oh yeah, I need to do negatives. Dang it. Okay. Negative and negative. And negative. Okay, so yeah, by default it's a max heap. Come on, big money, no enemies. Looks good. Okay, so there's Russ. And now you can see why that gave me the heebie-jeebies. That one's not easy. Yeah, Rust gives me a hard time, but not as hard as the time as it used to. So that's cool. Okay, and like I mentioned, if y'all have any questions, please do feel free to comment either on the video here, or I prefer for y'all to comment on the code, so then others would hopefully have some help as well if it is helpful, you know. And if it's not helpful for y'all, it's helpful for me at least. I really enjoy doing this. I think that well-written code that is concise and well expressed and self-documented is art. I think it's beautiful. Well, anyhow, we'll catch y'all later.